Hello and welcome back to Let's Code Physics. I am really excited to share with you some developments that I made off camera to our enemy ship navigation in Black Hole Battles. You can see he is behaving a lot better than he was at the end of last episode. This is still not perfectly fleshed out, but I have made some improvements. I found a couple of technical issues. Yeah, see, he dies right there after 1.5 passes. I've made a couple of technical adjustments that were mistakes on the last version, but I've also completely retooled how this ship approaches the next nearest black hole. So that's what I'd like to show you first. So in the last episode, this was the scheme that we were going with. The idea was that the enemy ship would identify the nearest black hole and the next nearest black hole, and if he was feeling particularly aggressive, he would move away from the nearest black hole. If he was feeling particularly defensive, he would move away from both of them, or if he was feeling particularly aggressive, he would move toward the next nearest black hole to sort of lead the player ship into danger. The issue that I realized, though, is that the curvature of this turn can be different depending on how the ship is oriented. So if the ship is oriented this way, like in the example that I drew, then yes, he would want to turn this way and eventually turn over this way. But if the ship were pointing down this way, so for example, if the enemy ship were pointing in this direction, then its trajectory would look rather different. It would turn in this direction, which is the opposite turning direction that we had set up. We had it I had set it up so that this turn direction was opposite of this angle, but this turning direction is the same as this angle. So I sat down for a couple days to try to figure out how to delineate one of those from the other. I'm still going to work on that problem, but I realized that there's still the issue of it needs to avoid this nearest black hole, and it's not necessarily going to do that following either of these two paths. So I went back to the drawing board. Here is a picture of my drawing board in my office. And I decided to go with a slightly different formulation. You notice there's no curvature on this one. We're just worried about the immediate vectors between them. I might be able to incorporate the curvature later, but for right now, this is what I'm going with, and this seems to be working a bit better. And so what I've done is I've said, okay, you need to look at the relative position vector between the ship and the nearest black hole and the ship and the next nearest black hole. So we're looking at different vectors than we were last time, because last time we were taking the nearest black hole as the origin. Now we're taking the enemy ship as the origin. And so what I've done is I've defined nearest black hole position, next nearest black hole position. And basically what I'm looking at now is whether the ship, if it were to head toward the next nearest black hole, would be heading into the range of the nearest black hole. So I've defined this. I originally called it safety cone. I later realized I needed to call it the danger cone because inside the cone is danger. Because if the ship heads on any trajectory inside this cone, then it's in danger of hitting this nearest black hole. So the geometry of this danger cone is determined by the distance between the enemy ship and the nearest black hole and by the radius of this black hole, plus probably a little smidge factor that I need to work in. And basically the way we can check it is that if this vector, the next nearest black hole, if this vector is outside the cone, then the ship can turn toward the next nearest black hole and probably safely ignore this one. If, on the other hand, say we rotated this black hole over to this side, this spot over here, then this vector would rotate this way and be inside the danger cone. And so if it's inside the danger cone, then the ship needs to turn toward the direction of this, I call it safety angle here. It's going to be called danger angle in the code because I realize this is danger, not safety. It's important to know the difference between danger and safety, probably. So that way it can get around this black hole and then head toward the next nearest black hole. And this little diagram it's not terribly well drawn, but it shows you, like, if you have a ship position here, then here's the danger cone. The next nearest black hole is inside the danger cone. Go ahead and pause to make your song references here. This thing is inside the danger cone, so it's going to coast along this way. And once it reaches a point, say about here, there's a new danger cone where this is now outside of the danger cone. So now it can start turning toward the next nearest black hole. The other thing I realized I needed to do was, instead of testing this code out in a 4 black hole system, I needed to test it out in a 2 black hole system. So right now the ship is has this as the nearest black hole. That is black hole number 0. I guess I don't have it printing that anymore. And then it's heading toward this black hole. So it's going to try to avoid this one, but head toward this one. And so it is well outside the danger cone here, so it is going to proceed on just fine. There we go. Oh, I need to scroll this down. Okay, but right now, this black hole is the nearest one, so now it's going to try to head toward this black hole. The problem is, you draw the danger cone for this one, the ship is now inside, or this vector is now inside the danger cone. So now it's telling me it's inside the danger cone, so it's going to try to coast along the angle for the danger cone. Of course, it's already got some momentum along that direction, so it's moving that direction, and it seems to be overcompensating a bit by turning this way. So I think I need to adjust how it behaves in the danger cone. But it just switched to outside the danger cone. And so now it's outside. It's going to start heading toward this black hole. And this is a point at which I need to have it switch, I think, from behaviors, because right about here, it should probably start turning this way. But instead it is still trying to head toward this one, and it doesn't try heading away from it until too late. And in fact, it's turning in exactly the wrong direction, right? It should be turning this way. So this is the point at which, or right about here is the point at which it needs to switch back over to the simple avoid nearest black hole maneuver, and turn around this way because it doesn't have the clearance radius to turn that way. So that's not necessarily an issue with the code as I've modified it now. It's an issue with being able to switch between the two parcels. So let me show you how I've implemented this. So here is our new subroutine, the go to next nearest black hole. So just like before, it takes 2 arguments, the index of the nearest black hole and the index of the next nearest black hole. I haven't really done anything with the aggro level yet. I'm now thinking, though, that this should probably be up here somewhere where the maneuver gets determined. So the next thing I need to do is figure out how the ship switches between these 2 behaviors. So this is the original avoid black hole. It's functioning just like it was before. So here it's getting the nearest black hole position, the next nearest black hole position. Oh yeah, one other thing I had to change. I realized that another mistake I had is that when the closest black hole is the first black hole, then it stores next closest black hole and closest black hole as the same value. So they were both coming out as black hole number 0 when I was testing it. And me going to 2 black holes instead of 4 helped me realize that, because the thing just headed toward the first black hole. And I said, why are you doing this? And then I had it print out what the values were for the nearest black hole and the next nearest black hole, and lo and behold, they were the same value. So to fix that, I did a couple things. First, I initialized the next closest black hole as the last black hole. So these 2 will not start out as the same value anymore. So that's good. The other thing I added is this conditional here. So it doesn't check, or it doesn't update the next closest black hole until the second iteration, until I is 1 or greater. So that way, it's always going to think of the close of black hole 0 as the closest black hole, because it's the only one it's checked so far. And so this code just makes it so that it's not going to evaluate next closest black hole until it actually has evaluated 2 black holes. In hindsight, it makes perfect sense. At the time, I did not realize that would be a problem, but that problem's been adjusted now. Oh yeah, here's where I had the print statement for the closest and the next to closest black hole. Let's bring that back out, just so that you can see that it is in fact identifying them correctly. All right, back to the show. Let's see. So here it's determining the danger cone. So the way it's doing that is it's taking the arc sign, because if you look at back over here, we want to get this small angle in here, what I'm calling safety angle here, what I'm calling danger angle on the other on the actual code. So we need the distance from the ship to the black hole, so that's the magnitude of this vector, and we need the width of this as the opposite side. Oh dear, I programmed that incorrectly. This should be the arctangent, not the arcsine. This is I looked at this and said, oh, it's alongside. That must be the hypotenuse. This is actually the hypotenuse. Well, let me make an adjustment to that right away. So let's go A tan 2. So I've discovered the difference between A tan and A tan 2 is that A tan, it just asks for a single input. So it's asking for you to calculate the opposite over adjacent, but you don't necessarily want to do that because that can give you infinities and weirdnesses and things like that. If you do A tan 2, it asks you for the opposite and the adjacent here. And so it's doing all the taking care of the special cases like the 90 degrees and 180 degrees and things like that. So you don't have to worry about the infinities. Really neat adaptation of the function there. So it returns the angle in radians whose tan is y over x. So that's opposite over adjacent. So I need the opposite side. That is the width of this thing over the adjacent side. And that is the magnitude of this thing. Okay, well, there we go. I'm glad I did this review with you. Found an error in my code. Although for small angles, sine is approximately equal to tangent, so it wasn't causing too big an issue, but for larger angles that does make a big difference. So I'm accessing the size of the black hole's circle collider, and since it's a circle, I can just put in the x or y component, and it'll just give me the diameter of it. Of course, since it's the diameter, I want half of that, so we need to divide this guy by... Actually, let's multiply them by 0.5. I try to avoid dividing whenever I can. I like to multiply better. So yes, that actually needs to be half of that because it's half the size. There we go. Well, thank y'all so much. I like this arrangement where I do all the banging my head against the desk off of camera, and then y'all just help me find the teeny tiny mistakes. So here it's determining the angle between the black holes. That's this ABBH, angle between black holes. So that's the angle between these two relative position vectors. So we already figured out the relative position vectors here. They are set up as correct relative position vectors as field point minus source point, or the thing you're looking at minus where you're looking from. And so I've got the angle between them, just evaluating the cross product here. And then I take the arcsine of them. I was having an issue with it calculating the cross product earlier, but I got that worked out. Oh yeah, that's actually how I discovered that it was identifying these as the same black hole, because the cross product kept coming out to 0 because it was crossing this vector with itself every single time. Yeah, pretty crazy stuff. So here I'm just taking the arcsine of this divided by the magnitude. Here we initialize the rotation direction, thrust direction. Another thing I decided to do that would help me modularize this is to determine the rotation and then determine the thrust. That seems to... I think that'll work out better in the long run to separate those two out, although I'm initializing this here. Although I suppose I need to make this a float. If I made this a float, I'll leave it as an int for now. Excuse me. Sorry, I've started drinking an herbal tea in the morning to help me reduce my throat clearings into the microphone. Of course, that means I take little breaks for tea slurps. So this is the ship angle, just like we've calculated before. But a mistake I had is that I was not adjusting it based on two things. I need to adjust it based on the fact that the ship's initial orientation is downward. So I've got it set up where the ship is pointing downward initially. In hindsight, that was probably not the best idea in the world. Why are you not? There we go. In hindsight, that was probably not the best idea in the world because now I'm having to adjust all the angles. But I figure the player starting, it's traditional for the player to start, kind of here on the screen. And so the enemy is coming in from that way. So I think it helps alleviate some of the stuff at the beginning of the game. Once I get all these modules set up, then all I have to do is design ships' behavior based on when they call their module. So I'd adjust it based on that, and the fact that this transform.rotation goes, let's click on the other ship, and the fact that this angle here, rotation, goes based on 0 to 360. Well, wait, now it's going negative. That's weird. Why is it going from 0 to negative? No, it was going from 0 to 360 last time. Okay, well, we will set that back to 0. I know it's working. It's working fine as I want now, so we'll leave that as it is. So anyway, I also need it to turn into negative 180 to 180 instead. And so I did a little diagram. Did not grab a picture of it, but basically this adjusts the ship angle into an angle range that's comparable to the way these angles are measured. Because the next thing I need, oh yeah, I also needed to keep my units straight. My students feel free to shame me in class for not remembering to convert my units. So here we've got the nearest black hole angle and the next nearest black hole angle. So these are the angles measured from the x-axis of these two vectors. So we've got their relative angles, but we needed the absolute angle from the constant x-axis. So that just takes care of this again using the arctan2 function to avoid any zeros and infinities and things like that. And so here we determine how the ship should rotate, and it's all based on the danger angle. So just like the pseudocode I have here. So if the angle between the black holes is less than the danger angle, so that's this first scenario right here. You've got the danger angle here. You've got the angle between the ships here. Clearly, the angle that these 3 points make is smaller than the angle that these two dashed lines make. And so in that case, the approach vector is in the danger cone. So it's going to tell it to make the rotation direction toward the danger angle. So whatever direction the ship angle is minus the danger angle, that's going to let it rotate toward danger angle. Otherwise, it can rotate toward the next nearest black hole angle. Once it's so in the else part here, it's outside the danger cone. We can approach with relative safety. And of course, I still need to add in a little smidge factor to the black hole. Where would I add that? I would add that to the... Okay, I've got the danger angle calculation here. So times the 0.5 f. So it's like we want to give the black hole a slightly wider berth, B-E-R-T-H. Black hole berth, B-I-R-T-H, is a wonderful, magnificent, terrible process that we will not be modeling today on this channel, but maybe someday. So let's multiply that by a smidge. Let's specify black holes. Actually, I know what to call it. Danger smidge. Wouldn't you love to have that as a superhero name, Danger Smidge? Like, all you do is go around and introduce just a teeny tiny element of danger to the situation. And actually what occurs to me is I could even make Danger Smidge a function of the aggro level. So if you're feeling only slightly, if the ship is feeling only slightly aggressive, it can have a wider smidge, but if feeling really aggressive, it can have a smaller smidge. And actually, so that needs to be 1 plus danger smidge. So this is the extra berth given to nearest black hole. And let me make a note to myself, can be a function of aggro. For right now, let's give it a 10% smidge. So this needs to be 1.0 plus. Yes, I know I need to write the next Asher intro, and I will get to that probably this afternoon. I should have brought my cell phone in here and cleared that out. Actually, what I need to do is snooze my push bullet notifications. There we go. Although actually, I guess those are popping up directly off of Google Keep. I don't need this anymore. There we go. And I definitely don't need this anymore. Let's see, 1.0 float plus danger smidge. There we go. Cool. So that adds a little bit to that. Let's see, where were we? Okay, and so, so here we're rotating toward the next nearest black hole, and here's where we determine the thrust. So the other thing I decided was that if the path is in this danger zone, the ship doesn't really need to be thrusting. I mean, I could be wrong about that. There's probably some cutoff point at which it needs to thrust if it's getting too close to this. I mean, if it gets too close to this, it needs to switch over to the avoid black hole subroutine anyway. But what I'm thinking is it can coast until it's pointing in the correct direction and then thrust out of the danger cone to get toward the next nearest black hole. And so what I've set up here is if the ship is in the danger cone, or if the path is in the danger cone, the ship is always at the corner of the danger cone, Brian. So if the path would push it into the danger cone, then we make the thrust 0. Otherwise, we make the thrust 1. Here we perform the rotation, which is great. And then another thing I decided to do was to move the thrust action out to another subroutine. The reason is because there are several. This is the same code for the enemy ship, for the player ship, for friendly ships, for merchant ships, whoever ends up in this game. And so if I ever discovered I needed to adjust this or wanted to make a change to it, I would have to change it everywhere. And also it's going to appear in each one of these subroutines that I know they're called classes or whatever, but I call them subroutines because I was raised on Fortran. Deal with it. I'm just kidding. You don't have to deal with it. You can tell me in the comments all about what I'm supposed to be calling them, and I will still call them subroutines. That's how the internet works, folks. This way I can just have the one line, and so I've got all the thrust controls in here. And so eventually I'll replace the player ship thrust control with this. And so basically it takes the thrust direction, forward, backward, 0, the thrust magnitude, because that can vary with the ship. It reads in the rigid body 2D of the ship, so it can actually apply the force. So I've got it adding the force, doing the rb2d.add force here, which means I have to bring in the force on the body. So this includes a gravitational force. I'm not sure if I like that, or if I want it to just export a new value for force on body and then have it add the force. But that's the way I've got it right now. So right now thrust has to be the last force added onto a ship. And so, so those are the changes that I made. It seems to work out a little bit better, even with that angle error and without the danger smidge. So with those changes alone, let's see what kind of behavior we get here. Oops, I need to zoom out. Okay, so I added back this print statement. So right now it knows that the closest black hole is 0. The next closest black hole is 1. It is outside the danger cone, and so it knows that it can head directly toward this one. But once it crosses that vertical line there, it's going to switch. Closest black hole is now 1. Next closest black hole is 0. It's still outside danger cone, so now it's going to try to head toward this black hole. And of course it overshoots because it's got a lot of momentum in that direction. Okay, and you see for a moment there, it was inside the danger cone. I think it should have been inside the danger cone. Maybe I just missed the print statement. Oh well, we'll worry about that in a minute. I need to be pausing and playing. So it's still outside. So now it's definitely outside the danger cone. So now it's going to try to turn to get to that black hole. Let's actually pan this over and zoom in here. There we go. Okay, so now it's finally made its turnabout. Let's see if those changes help it avoid that collision that was happening last time. It is still barreling toward this black hole. Okay, it is about to switch which black hole is closer. So let's go frame by frame here. Closest black hole equal 1. And boom, it just switched. Closest black hole equals 0. Next closest black hole equals 1. And now here's the issue: is the path is outside the danger zone, because this is the path that's going to try to go on. This is the path toward the nearest black hole. So now it's not going to do any evasive maneuvers toward this black hole. It's going to try to turn toward this black hole, and I think that's where the issue happens. Yeah, this enemy is about to fall into the black hole. Boom. Okay, so those corrections were small in nature. They did not help fix that. So the next thing that I need to work on is getting the enemy ship to switch between those behaviors, because obviously to get away from the black hole that was over here, it needs to turn this way, come around, and then try approaching the next nearest black hole. Okay, so I think that'll do it for today. I need to go do some work off camera, figure out how I'll have the enemy ship decide between those two maneuvers. If you've got some strategic advice for our enemy ship about how to switch between the two, let me know, and I will try out implementing it. Of course, it doesn't have to be the same for every enemy ship. Some will be more aggressive than others, and so all designs are definitely worth considering and worth trying out. So thank you so much for watching. I will see you next time. But he won't. He fell down a black hole. Bye-bye. Hey everybody, thanks for watching today's video. I have decided to try something different with my release schedule. I'm going to try scheduling videos to be released on Monday, Tuesday, and Thursday afternoons. I'm thinking this might result in more immediate views and discussion than posting them at 8 o'clock in the morning. Let me know what you think about that release schedule. Does it work better for your viewing habits? Does it work worse for your viewing habits? Let me know your thoughts in the comments below or on Twitter at Let's Code Physics, and I look forward to seeing you then. Have a good day. Bye-bye.